Hello, good morning. Welcome to the session about ensuring continuity of emergency communications and public warning with satellite applications. In this session, we will hear how satellites can also be used as a means to ensure the continuity of communication between emergency services and people, especially when the telecommunication networks are down. Okay, my name is Manuel Lopez. I'm Senior Technology Officer in EUSPA, in the European Union Agency for the Space Program. I would like to present very quickly the role of EUSPA, which is a new agency created for the space program. In the new regulation, we are contributing in EUSPA in several space programs. One of them is Galileo, other is EGNOS, Copernicus, GOTSATCOM. So I would like to say simply some words on Galileo, which is the European GNSS, the Global Navigation Satellite System, whose satellites are located in the medium Earth orbit. This is relevant for the discussion today. EUSPA is responsible for the service provision of navigation-related services. We have a Galileo Open Service. We have recently declared operational a Galileo High Accuracy Service. But also, we are working very hard to provide emergency-related services. We have the Galileo Search and Rescue Services, and in the future, also the Galileo Emergency Warning Satellite Service, which will be the focus of one of the presentations today.
So the next speakers are Laurent Arzel and Amélie Grangeat, and they will present the alerting the population via satellite and update from the Stellar project. So, okay, you will do together. Okay, fine.
Yeah, we do together. Hello, everyone. Thank you for joining us this morning. So today we are also going to talk about the stars, and we are going to talk about alerting the population via the Galileo satellites, and to tell you more about this Stellar project. So when I say we are going to talk at two voices. So Laurent Arzel with me. Please introduce yourself.
Yeah, so I'm Laurent Arzel. I worked at Telespazio France, and I'm the Stellar project leader. And I'm happy to be here with Amélie.
Yeah, so Amélie Grangeat, I'm working for F24 as a project manager for public warning system. So when we discuss about the Galileo satellites, why is it interesting for the public warning system? The goal of a public warning is to reach everyone, everywhere, immediately. That means to adopt a multi-channel alerting approach, because every channels you have may fail at one point or another, and the purpose is to be able to alert anytime. So you have a lot of advantages of each of these channels. So for instance, sirens, everyone hears about it, everyone is used to it, so it's a very important channel. It may fail when we are in a situation of earthquake. It's the same for location-based SMS, cell broadcast. All of these are very efficient channels, but they rely on local ground relay, and sometimes the local ground relay can be damaged by the situation or by the crisis. For everything which is mobile app, it's the same, it's very powerful, but you need to have data for that. It's the same for social network, it's the same for all these websites. So the idea in having this multi-channel approach is to add another channel which doesn't rely on a local ground relay. So this is the case for the satellites. So when we talk about public warning via Galileo, we talk about a technology which is made for mass market smartphones. Meaning in Europe, you may have heard about a legislation in 2018 that says that every smartphone sold in Europe should be compatible with the Galileo signal. So it's really made for mass market smartphones. It has no subscription fees because we are going to use the GNSS satellite as a GNSS signal that you already receive when you position yourself on a map. So there's no additional subscription fee. It's available when mobile network operators are done, which may happen in certain crises. Yesterday, you may have heard about the earthquake example in Turkey with mobile network operators down. It offers also a worldwide coverage, which is really important because, of course, Europe has a lot of different islands around the world. And this is for the everywhere, but we need to also alert them immediately. And the immediately is the latency. We have a 1 minute latency with this service, so it's very quick. And it's also important to be able to notify different situations. So the notification possibility for the public warning with Galileo is very small, can be very small, such as 50 meters, up to 5,000 kilometers so of diameter. So for giving you an idea, 5,000 kilometers is the size of Europe. So I've talked a lot about the Galileo itself, but I would like to introduce it first. So Galileo is a constellation made of 24 satellites. They are moving around Earth to ensure a global homogeneous coverage. And what you see when you are on the ground as a user in a European latitude is that you are covered at the same times by approximately 7 satellites above you that can reach you. So it's really redundant. Every one of these satellites can reach approximately 15,000 kilometers of range, so it really enables you to have a wide visibility on Earth. So the idea of the Galileo constellation itself is to offer a global, reliable, and secured service for positioning, but also for alert in our case. So concretely, how does it work? So you must first have an event, and all these alerting authorities need to assess whether or not they are going to issue a warning. Once they decide to issue a warning, they are going to send a common alerting protocol file to the ground infrastructure of the Galileo services. This ground infrastructure will transmit it and code it into certain bytes to the satellites, and these satellites are going to broadcast it over all the alert area. It's interesting to know that this broadcast will be wider than the alert area itself. The intelligence of the smartphone will recognize whether or not they are within the area and whether or not they are going to warn the user. So that's why we reach a very high precision in the warning area. In terms of warning notification, it looks like what you have on the screen. So it's a notification. When you click on it, you have all the alerts, the instruction, the description of the event, and also the ellipse of danger and the ellipse of warning and vigilance, sorry. So concretely, what we do here and what we present is the Stellar project. So it's a project funded by the European Commission, starting in 2022 and finishing in 2024. It's a consortium of different institutions. So we have Telespazio here, F24, but also EENA, the CNES, who operates the ground infrastructure, and Thales and ELNA Space. So the goal of this project, this specific project, is to demonstrate the Galileo emergency warning satellite service with demonstration, real demonstration across Europe, and to connect with national authorities to have a representative view on how it can be useful and how we can define this service. We are going to consolidate what we have already created based on all the feedbacks of this national authority to make sure that we fulfill the needs of this alerting authority. So concretely, the different demonstration we have already planned starts in June, so very, very soon, in France, in Toulouse, with a demonstration of a chemical accident. You may have heard about AZF in France, which was a major explosion. So we are going to simulate a similar situation and test the Galileo system there. We are going to do a similar chemical incident in Germany, in Leverkusen, where also a past incident happened in June as well. And then we choose to cover the east part of Europe as well with the Cyprus demonstration planned in October 2023. So here the idea is to test a different scenario and to test a simultaneous hazard. So we are going to test the tsunami alert on the same time than a high intense fire. So this is for testing the limit of the system on simultaneous hazards. And then we will finish by the most complex scenarios, which will be handled in Belgium and Luxembourg, where we are going to test this very sensitive question of the cross-border hazards. Here we are going to play a sentinel flood, across Belgium and Luxembourg, and we will send different alerts and check who receives it and that the border is well respected. So this is for a general principle of how the Stella project and the Stella prototype work. And now I will pass the floor to Laurent, who will explain the demonstration, the prototype itself.
So thank you, Amélie. So I will continue. So for this demonstration, we have developed an end-to-end prototype. It's a chain of 4 main components, starting with 2 interfaces for the authorities to monitor and use the service. Then we have central servers platforms to process the data and to connect to the Galileo secured infrastructures. And at the end, we have a mobile app which receives and notifies the alerts on a smartphone. So we start at the beginning of the chain with, in our prototype, we offer 2 ways of launching an alert. The first thing, simple one, is just by filling a blank form, by selecting parameters. And the other one is to use directly a CAP file, loading it into the system, and the system is able to match the CAP format. No need to explain, and Amélie will explain just after. So the system is able to interpret the CAP parameters and to convert them into the Galileo EWSS message parameters. And if it's not working for any reason, the system is able to provide a generic value by default to not block the system. And doing so, we facilitate the integration of this future service, of the future Galileo service, into the existing national PWS, and in particular those using the CAP format. I don't even know if there are PWS not using CAP format, but yeah.
There are.
Okay. Okay, so the message. So the message is encoded into the Galileo signal, so that's the basis, but you are only using 122 bits. So it's rather small, a small message. And each satellite is able to send a message every 16 seconds. So that's an example. So it's only a sequence of bits, but that's a real example from a test we did last week. And so clearly we have a limitation with the size, and so we cannot afford to encode free text information. So it's only predefined information. Still, the message carries all the necessary data to inform and instruct the targeted users. So we have designed the format to make it work with the CAP format, even though we have some parameters for which we have developed specific concepts. They are the ones with the little star. And I will go through them. So the first one is the target areas. So in Galileo, there are going to be ellipses. They are defined by a center, an angle, and a size. The system is able to automatically compute the ellipse based on a polygon, typically taken from a CAP format. And on top of that, so it's specific to the Galileo service, we can encode 2 ellipses in a single message. And the purpose is to have differentiated instruction in the 2 ellipses. So the red ellipse is the main ellipse in which you provide the normal emergency instructions. And the yellow ellipse in the yellow ellipse, we provide vigilance instructions. And typically, this yellow ellipse will be around the red ellipse. We have also invented something very peculiar for a very specific case. and it consists in providing a single unique instruction in the red ellipse saying, please evacuate and go to the secondary ellipse. And if you think about it a few minutes, it's a very smart way of indicating a specific geographic destination, like a building, an emergency center, somewhere, but only using predefined information, predefined instruction. And so that's one of the most, well, let's say, one of the important concepts of the Galileo service. We are using ellipse, and it's super flexible. Okay. So again, due to this size limitation, we have only 32 codes to identify the alerting authority, meaning that each member state will have up to 32 providers able to, well, authorized to connect and use the service. Also, the instruction will have to be picked up within predefined lists. And for the main ellipse, for the red ellipse, it's going to be 2 lists of 32 instructions that can be combined together. And for the secondary ellipse, is a single list of 32 vigilance instructions. We have also several types of library. So the first one is the so-called international one that each member state can use, and a national library, meaning that each member state will have the choice between using the international library or its own national library. And overall, it's a lot of possibilities to define an instruction while only using predefined information. Okay, so at the end of the chain, we have a smartphone receiving the message broadcasted by Galileo and a mobile app notifying the alerts under specific conditions. And the main conditions are that the smartphone has to be inside the target area, but also inside the country which has sent the alert. And once the message has been received by the smartphone, so it is stored in the smartphone, these conditions are checked continuously. So with that, we can cover the case in which the smartphone is moving, just that. And in particular, the smartphone is moving and entering the target area. And in this case, the smartphone will notify immediately the alert to the user. We have also specific notifications when there is no danger anymore, typically when the smartphone leaves the target area or when the hazard has expired. So there is no danger anymore, but still we keep informed the user. And so as explained, mentioned by Amélie before, the intelligence is within the smartphone. That's the smartphone doing the job of filtering and keeping up to date the notification. And that's it. So where we are in the project, in our path to the Holy Grail, the wide service adoption. So far, we have consolidated the concept, the service concept. We have developed an end-to-end prototype, and we are now preparing a field demonstration with 4 member states. The first one being in France in June, so it's very, very soon, with the support of Romain Moutard from the French Ministry of Interior. And the other demonstration will follow until the end of the year. In parallel, we will work, and EENA will work on user segment adoption, for example, the standardization, and that is to ensure a smooth transition towards the final operational service. And at the end of the project, we will organize a workshop with all the demo participants to critically review the demonstrated service and concepts to draw final recommendation for EC and EUSPA to proceed with the service implementation. And I would like to thank you and to thank Amélie as well.
Thank you.
Thank you, Laurent. Thank you, Amélie. Okay, before moving to the questions, I would like to complement with one more slide.
Okay.
Could you please?
Can you switch to yours?
Yes. Next slide. Can you, Laurent? Yeah, next slide. So it's simply to present a call for proposals that is now open. It's fundamental element grants. It's for the development of Galileo-enabled devices for emergency warning satellite service. So we are launching this call with a budget of 1 million euro with a co-financing rate of 70%. And the deadline for submission of proposal is 31st of May. We are preparing a workshop, a webinar, I would say, next week on 28th of April at 10. So information about this webinar is in the QR code, also written the URL address there. So the objective of this call for proposals is to develop Galileo-enabled devices for this service, with focus in mass markets, sports, automotive, so several applications. And the idea is to develop this prototype to be ready for the market once the service is ready. So, okay, now I think that we can move to the questions and answers. Okay, is there any question from, please?
Thank you very much. I'm Vanessa Gray from the United Nations. I represent the International Telecommunication Union. So obviously our interest is in particular for the developing countries, so this is a very exciting development. One question, did you look at, when you're talking about reaching populations over their devices, is there any study on understanding how many people can currently in Europe be reached using Galileo over their smartphones, and how many, or other way around, how many people will not be able to be reached? Because that is obviously, you know, for developing countries where not everyone has a smartphone, eventually that's going to be a big question. And the other question I have, yesterday we already heard a lot about cell broadcast and location-based SMS. So my question, I guess, is eventually these systems, will they be integrated? That means, does a user actually know whether something on the phone is location-based SMS, cell broadcast, or over a satellite? Is this something, you know, eventually that will sort of all feed together? Thank you.
So I'll take the complementarity with location-based, cell broadcast, and satellites, and I guess you will answer on the devices. Okay, so it's a very good question. So yes, it's made to be integrated in the public warning system of the different countries. So meaning countries haven't waited for the satellites to exist for having a public warning system, and they are already implementing technologies such as location-based SMS and cell broadcast, and this is something we encourage. The satellite is a complementary solution because it doesn't enable a free text, so you must have predefined instruction. It's already a lot, but it's really complementary with specific instructions you can push via location-based and cell broadcast. Currently, the smartphone is not able to detect whether you have received a location-based SMS, a cell broadcast, or a satellite notification, so you will receive several notifications. But the idea is that this trigger of the satellite is triggered via the same kind of platform that triggers location-based SMS, cell broadcast, and emergency communication via satellite. So the coherency is ensured by the alerting authority itself. Thank you. And for the devices?
Yeah, for the devices. So within the Stellar project, we don't have this kind of study, even though we are questioning ourselves because we are targeting the same objective of like a wide adoption. We did some study in the past And so there are many answers, many dimensions to answer your question. First, well, the real, let's say, key parameters is whether you will be reached or not, like the probability of reaching someone. And you have plenty of parameters in that, like first you need the smartphone able to receive Galileo. So in Europe, should be the case, thanks to the regulation mentioned by Amélie. Also, you have to be outdoor. What else? Also, just if I bring the question to just now, it's not working. It's not working because even though the message is received by the smartphone, the useful data are not released to the OS and to the software layer of the smartphone. So the message will be received, but it will be not released to a mobile app or to the OS to notify the alert. So that's not the case today. So this is something also to be changed somehow. And that's the part of the work we will do with EENA to further to support the adoption of the service from the authorities to the end of the chain to the citizens. But while in the past studies, it was very, very clear that the huge benefits will go to countries with no infrastructures, with nothing, while even though it's a good idea to have multiple channels to warn the citizen in Europe, Galileo would be super useful in countries where they have nothing. And it costs nothing. It's there. We just need to operate the service. It's few people in a center somewhere in Europe, and that's the same cost for whatever the number of countries will use it. And I hope we can discuss even more during a coffee break, but it's a question.
Laurent is mentioning the technical obstacles, but there are political obstacles as well.
Yeah,
At the
but I would like
world
to avoid
adoption,
that.
there's a huge political discussion.
Michiel Scheerlink, Belgian National Crisis Center. You already mentioned that people have to be outdoors to receive the message. Can you further clarify this? So is there no case in which people are in a building where they will be able to receive the message? Also, are there other interfering circumstances that can cause someone not to receive the message? For example, mountains or a heavily forested area or large buildings nearby?
Okay, thank you for the question. It's for us, for GNSS specialists, it's a very classical question. So it's by definition, GNSS signals are blocked by structures, any kind of structures. So let's say, for example, here, we don't receive GNSS signals. But there is no, well, it's, if you are close to a window, like even in an aircraft, I did that on my way from Toulouse to Ljubljana, it's working. In a car, it's working. In a train, it's working. In a building, where if you have a window, maybe, I don't know, we have to test that, but 5 meters from the window, you will receive the signal. The fact is that it's simpler to receive a warning message in Galileo because you need a single signal, while for positioning, like using Google Maps indoor, only with GNSS signals, you need several of them. So it's easier. And in theory, the GNSS signal bounce over the structure. So maybe, by chance, there is one signal that could reach me here because it's bouncing each and everywhere. Well, it's doubtful here, but it's still possible. So mountain, the same. But mountains, except if you are at the bottom of a canyon, like very narrow canyon, it's, well, outdoor will work. Even in a canyon, you will see part of the sky, and it's good enough because we have seen there are a lot of satellites in view all the time. Et c'est quoi le reste de la question?
You covered all the points.
Yeah. I have another answer to that. So we are launching with EUSPA a new project to cover this case of indoor warning. So it's quite simple. The idea is simple, to put a receiver, let's say for this building, on the top of the building, and the receiver is super cheap. We don't need specific receiver, just a normal receiver. You put it on the top of the building, and you can connect that to any kind of sirens or indoor system to warn the people, and that's it. And so we are launching a project with Manuel called, for the moment, EWOKS, and we'll start very soon. So we have solution for this limitation.
Hi, can I have also a question? My name is Anastasia Lujanet. I'm from the Ministry of Interior of Latvia. I'm wondering if there is a kind of certain risk of war due to all the situation in Ukraine now, and I think the Eastern European countries are quite feeling not very good. At the moment, have you thought about testing the solution in terms of kind of war? I can imagine that in case something happens, the mobile network will be down, and the small countries, I mean, it's quite really a question of some hours. Like, will your project, will the satellite communication help in this situation? Maybe it's a question of testing for this purpose. Have you thought about it? Can you maybe give some advice, some idea? Thank you.
So it's a very good question, and thank you. And indeed it's an important topic that we cover in the concept definition. Meaning, in the event category, you have all events that are such as airstrikes or missiles launch or anything. So it's already encoded in the system that you have such kind of system of situation, and you have specific instructions linked to it. For the test itself, so the test of whether we can be, I don't know, hacked or whatsoever, this is outside of this project, so it hasn't been tested within this project, but the service itself is designed for covering this case as well.
Okay, maybe Manolo, you can complete, but in the service, there should be another service protecting this service and the other Galileo service by providing an authentication means, like avoiding the signal being spoofed, like with fake signals, with fake alerts. That's it. But if the system is down, it's down. If the system is jammed, like we can see regularly in Ukraine, there is nothing we can do.
Thank you.
Okay, I think that it's time to close the session. So thank you very much to our speakers.